Welcome friends, welcome to my YouTube channel. In today's video, we are discussing about the energy interaction with Earth. In the previous video, we are understanding that different types of scattering process when we are imparting energy on the objects. In this video, we are understanding about the different type of energy interaction when we using the active type remote sensing for for our image interpretation. In this video, we will also discuss about the various scattering and reflection types. Now, first, that is the important topic for selecting of sensors for remote sensing. Which types of bandwidth we have to require to capture for our remote sensing procedure. The accuracy also depends on the types of sensors. We have previously discussed about the various types of sensor that are available in our remote sensing process. Spectral sensitivity of the available sensors are also very important parameter in point of view of our image processing. The available atmospheric window in the spectral range is generally we have to consider. We are showing in previously that what are the spectral wavelength has been present and how much amount of wavelength are reflected from the different types of object, and we have to sense that. Source of magnitude and the spectral composition of the energy is present in the particular range. So we have to decide that how much magnitude we have to select for that particular sensor. If you want to cover the large area and want to identify the in-depth analysis of that particular object, we have to find out that particular spectral composition of that emitting source of energy. In the present, some of the multi-sensor sensors are also available. So for that, for using that sensors, we have a multiple and narrow wavelength range we have located during our remote sensing process. Now energy interaction. We are knowing that when we are imparting some of the energy onto the object, some of the part of that energy are reflected, some of the part of energy are absorbed, and some of the part of energy are transmitted through that body. We have only used that reflected energy because we cannot sense the transmitted energy or absorbed energy. We have to use reflect energy, and then we have to identify how much amount of energy is absorbed or how much amount of energy is transmitted. Now we are moving to the reflection. It is the process in which the incident energy is redirected in such a way that angle of incident is equal to the angle of reflection. That is called reflection. We have previously seen scattering. Scattering is different from reflection. In the scattering, the angle is not properly defined in any how manner that can be traveled in any direction without correlating with that angle. So we have to identify that what is the reflected energy and what is the scattering energy. It should also depend on the roughness of surface, and it is also depend on the relative wavelength of incident energy. If we are imparting some of the energy like light energy onto the mirror, they are reflecting at some reflecting angles. But if you are imparting light on the white walls, they are scattering. So that are the difference between the reflection and the scattering. Now there have been another types of different reflections. when we are imparting that types of some of the energy on the earth's surface. One is the specular reflection. In that type of reflection, that are perfectly reflected with defined angle, and that surface is perfectly smooth. Next is the diffuse reflection. In that type of reflection, the earth's surface are not smooth. That are the any angular disturbance on the surfaces. So the reflection may be also diffused. In the diffuse reflection, there have been some amount of wavelength are reflected in that different manners. Like we cannot identify what angle they can reflect it. They are reflected undividedly. In the specular reflections, we are seeing that which wavelength we are imparted that are perfectly aligned with that particular angle. Now, in that diffuse reflection, when surface is smooth and flat, and specular reflection when the surface is rough. Now, we are seeing the four pictures in which the first is the ideal specular reflection. But in the practical cases, that angle of incidence and angle of reflection are not same. That may be different because all the surfaces are not properly smooth. Or especially in case of our Earth's surface features, no smooth surface is available like a mirror. In the ideal diffusive, all the wavelengths are scattered equally, but that case is also not possible. Nearly specular, that is the practical cases. In the actual phenomena, nearly specular cases has been formed. And in the near diffusive figures, we are seeing that some of the amount of energy are highly reflected and some of the amount of energy are lowly scattered. So the near diffusive case are also has been created in the natural phenomena. Now that are the formulas for spectral reflection and spectral signature. Like how much we can calculate the how much amount of energy of wavelength are reflected from the particular object. It is called spectral reflectance. That formula is that energy of wavelength lambda reflected from the object upon energy of wavelength incident on the object multiply by 100. So that ratio gives the amount of reflection with the earth's surface features. Next is the absorption. Some amount of energy or the wavelength are absorbed by the target. We are knowing that some amount of energy are absorbed like a black body radiation. A portion absorbed by the Earth's surface is available for emission as a thermal radiation because that absorbed energy are reflected as a thermal emission. Like during the daytime, all the sun energy are imparted, but some of the wavelength of sun energy are absorbed by the our atmospheric gases, and that should be released as a thermal thermal energy. So the night temperature doesn't fall below the expected limit. Like a carbon gases are the one type of absorption example. In that next transmission, we have to choose that our medium when we have to transmit the our different wavelengths from the source to that our target object. Between that, we have to allow to pass through the target. It is called the transmission, and some of the energy also transmitted through the object also. So that can transmit from the one object to another object. Atmosphere is a one type of transmission medium. That is the one type of object, but we have to that is allowed to pass through them. It should also depend the changes of the velocity and the wavelength of the radiation. If the wavelength of radiation is very shorter, So more amount of energy are transmitted through the any object. And also we are knowing that the transmitted energy may be further scattered or absorbed in the medium. We are seeing the another example of transmission and the reflection. Now see in the figure is that one amount of energy is incident, some of the transmitted, some of the absorbed and some of the reflected. Now transmitted energy, so our one person are seeing on the corner of that pond, and some of the piece of image are seen here, right? Actually the piece is here but some person see is here, and the actual depth is that, but that depth is apparent depth, like that are the visualized depth. One other example of glass, we are seeing that tube is under the glass but tube is shown cut from here. Why? Because some of the energy are transmitted through that and some of the energy are reflected on that way. So we can see the difference between the transmission and reflection. Refraction and reflection both are the different. We are understanding that the reflection are some of the energy are reflected, but refraction is means the path of the energy are changed from one direction to another direction, but actually is that, but apparent is that, actual phase is that, but apparent energy is visualization is that, so that is called refraction. That is due to medium of energy that travel through. In that case medium is water. Now one question will arise in mind, that what is the reflection, absorption and transmission. Energy incident on a surface may be partially reflected, absorbed or transmitted. Which process take place on surface generally depend on the following factor. How much amount of energy reflected, absorbed or transmitted. That are the dependent on the wavelength of radiation, angle at which the radiation interacts the surface, and composition and physical properties of the surface. Like one of the element like carbon gases that are the absorb the ultraviolet rays. The relationship between the reflection, absorption and transmission is given below, and that should be given by this formula. EI lambda is equal to ER lambda plus EA lambda plus ET lambda. So ER is equal to reflected, ET is equal to absorbed energy, transmitted energy, sorry, and EA is equal to absorbed energy, and ER is equal to reflected energy. EI is equal to incident energy. So the total energy is the summation of all three energy. Now reflection versus scattering. That are the difference between the reflection versus scattering. Incident energy is redirected. In the reflection, all the incident energy is redirected. In the scattering, a special type of reflection, because all the incident energy are not redirected into one direction. That is redirected, but it into many direction, or it is called the diffuse. The angle of incidence and angle of reflection are same in case of reflection, but in the diffusion case both the angles are not same and diffuse in many directions. The reflected radiations leave the surface at the same angle at its approaches, but in the case of scattering, that is called diffuse reflection. That is not a perfect reflection, that is the diffuse reflection. Now we are seeing the next difference, like reflection versus scattering. What is the reflection and what is the scattering? It should be reflection and scattering are depend on the roughness of the surface with respect to the incident of wavelength. If the in that next two sentences we are seeing that if the roughness of surface is lesser, so the incident of wave energy more. We have to incident of wave energy we have to put more. If the smooth surface, so the reflection is more. And if the roughness of surface is more, so incident wavelength is smaller. We have to incident the wavelength is smaller, and the rough surface is the scattering has been done. That are the one phenomena I have created to understand if the roughness of surface is increased, what type of phenomena is occurred. The roughness of surface is increased, the proper reflection is not done, but scattering is done, and the incident wavelength is smaller. We have to use, and roughness of surface is greater. Roughness of surface generally control how energy is reflected. That is the two types of reflection, specular and diffuse reflection. We have previously discussed that. Now we are moving to the image resolution. If we are imparting some of the energy that can be reflected and that are converted into the form of image. Now image resolution refers to the number of pixels in unit area or digital photo or the image. Its terminology used in both traditional and digital photography. And pixel defines the quality of image. If our image pixels are more like 180 by 720 pixel, 180 pixel means 180 dots per inch has been 1080 dots per inch has been given for that quality of photograph. We that shown the three images has been given. One resolution is lower, like that is the pixel ratio is lower. Second resolution is some of the eye compared to first, and third is the higher resolution image. So in the third image we can see clearly all the features. Now there have been different types of resolution. We are seen generally in case of our traditional photography, that is the visual resolution. In that case, we have been spatial resolution, temporal resolution, spectral resolution, and radiometric resolution. That are the four type of resolution in case of remote sensing. In the spatial resolution, the pixel size of satellite imaging covering the surface. How much amount or area of the surface will be covered within the how much amount of pixels. The high spatial resolution is 0.41 to 4 meter and lowest spatial resolution is 30 to 1000 meter. So 1 pixel image 30 spatial resolution means 1 pixel in image is 30 by 30 meter in length, and 4 meter spatial resolution means 1 pixel image in 4 by 4 meter range. 1 meter means 1 meter area is covered within the 1 pixel. But in case of our traditional photography, that is the ratio is become a very high. For that type of resolution, we are using 1 square inch per 1800 pixel. And in that case, per meter, we have 1 pixel only. Now that are the seen the some pictures that shows the different types of resolution, and there have been some different pixel resolution, like that is the 1 by 1 pixel, 2 pixel, 5 pixel, 10 pixel, 20 pixel. The image area cover are same, but there are the resolutions are different. So 100 by 100 pixels shows the accurate pictures. Now, one another example of spatial resolution, 40 by 40, 80 by 80 and 320 by 320. See clearly that are the difference between the resolutions. Now next is the temporal resolution. Temporal resolution specifies the revisiting frequency of satellite sensor for a specific location. We are knowing that satellites are many times captures the pictures of same area and that are combined with each other, and we are increasing or enhancing that resolution of pictures. For the high temporal resolution, we are using the 24 hours, right? And minimum temporal resolution 4 to 16 days, and for low temporal resolution we are getting the image more than 16 days. Now, July 1, July 2, that are the 16 days temporal resolution. Means first July 2 and second is the July 18. And we are merging that. So the two images only are NSing that resolution properties. But in that case, July 1, 12, 13, 23 and 3. So 11 days. So that should be maximum temporal resolutions. But in the case of August 3, we have used the two time sequence. So that time, at that point, we have two images. So their resolution is more. Next is the spectral resolution. It is the ability of the sensor to detect the small differences in wavelength. So we are getting the more detailing of this photograph. It specifies the number of spectral bands in which the sensor can collect the reflected radiation. That parameter or that resolution are depend on our sensors that receives the reflected energy. If you have DSLR and the another our mobile phone camera, that are the difference is the sensor. Another difference is lens, but sensor plays the great role when we have to get the detailed image, like the actual clear picture and 3D image. For high spectral resolution, 220 bands, black and white film, there have been only zero point 0.4 micrometer to zero point 0.7 micrometer. And in the color film, zero point 0.4 to zero point 0.7 micrometer wavelength spectral resolution bands. In the medium spectral resolution, 3 to 15 bands, and low spectral resolution, there will be only 3 bands like blue, green, and red. So our image only shows the blue, green, and red images. And in the high spectral resolution, we are seeing the 220 bands, like we are seeing the 220 colors with respect to that different spectral resolution or different emitted wavelengths. Now see, that is the example of black and white photograph. So that are only shows the three colors. We are seeing blue, green, and black. And that is the single sensitivity device. Blue, green, and red. But in that type of image, we can't see what are the color of this platform, what are the color of this cloth, what are the color of these objects, what are the color of these leaves. We are generally assumes that the tree is having a green leaves. But in the actual case, if we do not know tree having a green leaves, so we cannot identify what is this object is in actual. Now that is the color image. In that, we are also identify all the object with respect to its colors and materials. We are knowing some of the materials like metal having a black color, cloth having some of that color, that having platform having some of the different color, cup having some of the color, leaves having some color, and we can classify. Next is the radiometric resolutions. It measures of sensor's ability to discriminate small differences the magnitude of radiation with ground area that corresponding to a single raster cell. So if the greater the bit depth means number of pixels per bit. So our radiometric resolution is higher. In the AVHRR sensor, it stores the 2 raised to 10 bits per pixel, means 1024 bits per pixel, as opposed to the 2 raised to 8 bits per pixel, that is the Landsat sensor records. That is the 2 raised to 8 bits. Landsat satellite records the 2 raised to 8 bits per pixel. 1 bit means 2 raised to 1. Like that only carry the 0 or 1. Computer stores the within the binary languages like 0 or 1. So that can carry only the one features of cell like black and white. And in the 2 raised to 4 means 16. So that can carry the 15 bandwidth, that are the different sets. And 0 raised to 255, so that can gives the 255 different pixel colors. Now see 8-bit image 256 gray shade. That shows some of the clear 4-bit image. We cannot see there have been some white shades, and in that 4 gray shades 2-bit, that is the 256 gray shades, and that is the 4 gray shades only, and that is the 1-bit image. That is the one of type black and white image. We cannot find any detailing like eyes, hairs, and any other patches or the any other shapes of our men. Now comparison of satellites based on resolution. There have been different satellites: UOES, Landsat TM, Landsat MMS, WIFS, CWIFS, AVHRR, and MODIS. There have been a different spectral and temporal resolution. There have been spatial resolution is 1 kilometer. So that is very poor. We are seeing that only 1 pixel in 1 kilometer. So that resolution is very poor. Spectral resolution is 1 band. So that can only gives the black and white image. Only black and white. So that is very poor, and that resolution we cannot expect how much amount of features has been covered that. Temporal resolution is 50 minutes, so that is the very excellent because many number of pictures has been captured by this satellite. Landsat has been 30 meter. That resolution was very excellent. We are previously seen that, and the spectral resolution is 6 bands. So we can classify somehow, but it is a good, not a excellent. And that temporal resolution is 2 weeks. Like that can capture the one area at per 2 weeks at one time. So that is the very poor. Landsat is 75 meter, and that is the 4 band spectral. So that is the very fair. And 2 weeks temporal resolution is very poor. WIFS and CYs having also same resolution, but it is poor. Modi is having also poor resolution, but it is the spectral resolution is high, like 360 bands. It is the excellent, and that is the one day. For that, in case analysis, that is a very useful. But nowadays, latest satellites give the accurate real-time data. So that temporal resolution is 2 minutes, 5 minutes, 10 minutes, and as that same. Now we are moving to the remote sensing applications. We are seeing what is the remote sensing. There are different parameters, there are statistics, there are the different processes, and many other things. But where we have to apply the remote sensing? A software application that process the remote sensing data. Enable the generating the geographic information from the satellite and airborne sensor data. In the now present, we are seeing the China-India dispute land by the satellite. So we can identify what type of structure they can build and what are the movement of military exercise has been done at that place. Read the specialized file format that contain the sensor image data, like georeferencing information and sensor metadata. Like in data geo geo mapping of our land. There have been also some of the popular remote sensing file formats like GeoTIFF, NITF, HDF, and NetCDF. That are the formats. First application, one of that is a flood estimator. In that type, flood estimation is very important at that time when the flooding is occur. We can identify the how much amount of loss has been done due to flood and how much amount of water are spread to that area. Next is the earthquake estimation. That are the very important application. At the time of earthquake, we have not any other devices to carry out the loss assessment. For in that case, we have to see that our remote sensing image, and we can identify that how much losses has been done. Next is the weather map. Most of application of remote sensing are for weather map. For that, we can classify classify the weathers like clouds, tornadoes, and another hurricanes has become produced or moving into what direction. Or we can predict the direction of that hurricane by using the different models and software. So we can save the life of people and minimize the damage of properties. Next is the crop yielding. Now in the present era, we are using the remote sensing to find out how much amount of crop is being produced. Next is the tsunamis. In the case of tsunamis, we are previously identified that how much amount of earthquake has been occurred and where the tsunamis has been hit to at that cost. Next is the forest fires. If you want to estimate that how much area of forest is covered under the fire, that is the very useful in that case. Next is the regional planning. Based on that topographical features and the availability of different resources, we have to plan our structures and that infrastructures. In case of road networks, rail networks, industrial zones, residential networks, commercial networks also. To provide the surveying in inaccessible areas. Like if you want to find out the height and the different features of mountains, so that is very difficult for land surveying equipments. But in case of remote sensing, that is very easier and effective way. Flood and drought warning. That is the very important applications of remote sensing. Flood and drought warnings. Now some of the advantage and disadvantages of remote sensing. It provides the data of large area. Second advantage is it is the data of very remote and inaccessible regions. Like if you want to find out the condition of our Himalayan mountain, so that is very difficult in case to see there, reach there and analyze that areas. But remote sensing gives the accurate data. It is able to obtain the imaginary of any area over the continuous period of time through which there any anthropogenic or natural changes in the landscape can be analyzed. It is relatively inexpensive when compared to employing a team of surveyors. It is easy, rapid collection of data, rapid production of map or interpretations. Now, there have been some disadvantages of remote sensing. The interpretation of imaginary requires certain skill level persons. Next is the needs cross verification with ground survey data. Data from the multiple sources may create the confusion. Objects can be misclassified or confused. Distortion may occur in image due to relative motion of sensor and sources. Thank you. That chapter we are ended here. And in the next, we are understanding about the different image interpretation techniques and the phenomena. But in that case, we are completing our first module of the fundamentals of remote sensing. Now we are starting our next module like image interpretation techniques. I hope you are understanding the various concepts very well and you are preparing so much and that can be helpful in your preparation. Thank you.